Hello. In this video, I'm going to explain the concept of starvation as it applies to computer processes being run through a CPU. Each process or job on the computer has to use the CPU in order to run, but since they can't all use it at the same time, they take turns. This is where the scheduler comes in. It's the thing that decides which job out of all the ones on the system that need to run will actually get to use the CPU core next. Jobs come in and are scheduled in an order determined by the scheduler. The scheduler follows an algorithm that helps it choose the CPU's next job, but some of these algorithms come with major drawbacks. One of these drawbacks is starvation. Starvation happens when a job can't finish because it's not being chosen by the scheduler to run. It's therefore starved of time with the CPU and never gets to complete. There are some algorithms, though, that can avoid starvation entirely. For example, your scheduler could use the first in, first out, or FiFo scheduling algorithm. With FiFo, jobs will be scheduled as they arrive. There's no reordering. The scheduler will give each job to the CPU in the order they are received. It will also complete each job as soon as it is given to it, running them each from start to finish in one whole block. This avoids starvation entirely because each job will be run in time, but it also comes with problems. Unless you're in a system where all the jobs are pretty short and run for the same length of time, FIFO can be very slow. Whatever job is being run at the moment is going to keep running until it finishes, so long jobs can clog up the line. Because there's no ordering, long jobs at the head of the line will make all other jobs wait until it is completed to get their turn, even if they were much shorter. So we came up with other algorithms that would help us run our shortest jobs first. One of those algorithms is shortest job next, or SJN. With SJN, every time the scheduler needs to pick a new job, it always picks the shortest one available. This is nice because processes that take a long time can now be run after processes that go thousands of times faster. The problem, though, is that new jobs can be coming in all the time, filling the list back up. If the jobs never stop coming in, then there's a possibility that a longer job may be continually preempted by a shorter one. Here we can see that job number 1 is picked first because it's only 20. It's running, but while it's running, job number 3 that is of length 10 and job number 4 that's of length 15 arrive. So when job number 1 finishes, the scheduler picks the shortest one available, which is job number 3, and it begins to run job number 3. Then when that's done, it picks the next job that's the shortest available, which is job number 4. It starts to run job number 4, and while that is running, job number 5, which is of length 10, arrives. So when job number 4 is done, it picks the shortest one available again, which is job number 5 of length 10. Runs job number 5. While that's running, job number 6, 7, and 8 all come in. These are all also shorter than 40. So you can see here that if at least one job with a runtime shorter than 40 comes in every time a job is running, then job number 2 may never run. If the job that comes in is always shorter, it will never be chosen by the scheduler because the scheduler is always going to choose the shortest one available. And this is starvation in action.